Let's consider the following problem. You have 50 people work for your company. 15 are women, 35 are men. And you're going to randomly choose 10 people to talk to about their opinions on new HR policies. So you want to know what's the chance that of the 10 people you talk to, 0 will be women, 1 will be a woman, 2 will be a woman, etc. So you might think you'd use the binomial random variable because you have 15 women, population size is 50, so there's roughly a 30% chance that each person you pick will be a woman. Now the binomial won't quite work. We'll do the calculation anyway. Why not? Because if the first person you pick is a woman, then the chance the next person is a woman will not be the same 15 out of 50. It would be 14 out of 49. And if the first person was a man, the chance the second person would be a woman would be 15 out of 49. So basically the chance that each person is a woman will change, and the binomial does not allow for that. But if your sample size is less than 10% of your population size, the binomial gives you good probability results. But if the sample size is at least 10% of the population size, you probably want to use the hypergeometric random variable to account for the effect of sampling on the chance that the next person is a success or failure, or a woman or a man. But if you did use the binomial, what would you get here? So you could do binom dist or binom dist range. Okay, so number of successes would be this. Okay, we're going to look at 10 women, and the probability we said was 0.3, and if you say false, you get the chance of 0, 1 through 10. Now if you add those up, you should get 1, obviously, because you can only get 0 through 10 women there. Okay, but that is really not the right answer. So we want to use this hypergeometric random variable. Okay, instead of, I don't get exact probabilities in all situations when you're sampling without replacement. In other words, you can't pick the same person twice. So if you go to the if you type in hyper, I'm pretty hyper tonight, had too much caffeine. But basically, if I go then to the function wizard, okay, so this is the number of successes in the sample. We want that to be 0 in this case. The number in the sample will always be 10. Okay, this is the number of successes in the population. The success is a woman, that will always be 15. And the number in the population size is 50. And I want the word false here so I don't get the cumulative probability. We'll check out the cumulative probability later. So there I get 0.017. I can show you that formula if you were to type it in. Now these probabilities will add to 1, but they are a lot different. Okay, so here we get 20, well, not a lot. We get 30% instead of 27%, but that's a pretty big difference. But these probabilities will add to 1. But the ones in yellow are more correct. Okay, 0.999 to 6 or 7 decimal points. Now, if I wanted to get a cumulative probability, the chance of 4 or less, which would add up these numbers, we could do it that way. But there is a function to do that, change false to true. So 87% chance we get 4 women or less, okay, which is pretty high. But now if I would do that hypergeometric again, okay, so a function wizard makes it easier because I forget what I'm doing. So the sample successes would be 4. The number in the sample is 10. The population successes is 15. The number in the population is 50, but if we say true here rather than false, we get a cumulative probability, which is exactly what we got there. So in either case, I mean, it doesn't matter. We could add up 0 through 4, but it's a lot easier to do that cumulative right there with the true rather than the false. Now the binomial would say, okay, I got 10 trials. The chance of success, I'd say each time was 30%, and I'd say 0 through 4, and that's going to be 85%, which is a bit different. So that concludes our discussion of the hypergeometric random variable. Again, you use this if you're sampling without replacement, and basically your sample size is at least 10% of your population size. And this random variable can be very important in auditing if you're an accountant who does auditing.
Okay, so thanks for watching, and there's a free course, a free 21-day course from Dr. Winston, and all of these videos are coming from one of 3 books. So first, this one, which you can see here at the top of the screen, Microsoft's book, which has 355 reviews, and then it's, let's see, 4.6 stars. It's coming from this book as well, his marketing analytics book, which is down here, and you can sort of see 4.5, or his newest book, his analytic stories book, which is here. And with that one, you can see it's 4 point something, or maybe even 5. I don't think it's 5. Yeah, 4.8. And so, yeah, anyways, in the description, there's a free 21-day course from Dr. Winston, or you can go to excelwithwayne.com/free, and it'll be there. But again, thanks for watching, and if you have any questions, just please let us know. Thanks.